Good morning. Today we're going over Unit 1, Lesson 4, Convert Repeating Decimals to Fractions. Problem number 1, 0.7 repeating. So in class we generated 4 steps on how to set the repeating decimal up in an equation and solve it at the very end and get it turned into a fraction. So step 1 was to set the repeating decimal equal to x. So we're going to say x equals 0.7 repeating. Next, we have to count the number of repeating digits and multiply by that number of tens. So that many number of tens. So we have one repeating digit. It's 0.777. So that's just one digit. So we're going to multiply both sides by 10 to the first power, or just by 10 one time. That gives us 10x equals, when you multiply a decimal by 10, it moves the decimal point over one place to the right, giving us 7.7 repeating. Step number 3 says subtract a single x and its value from both sides. So looking back at this part right here, where it said x equals 0.7 repeating, we're going to subtract a single x from the left-hand side and subtract 0.7 repeating from the right-hand side. Remember, with equations, you got to think of it as a little balance beam. So you got to make sure you maintain balance on both sides. So if I multiplied both sides, or one side by 10, I need to make sure I do it to both sides. If I subtract x from one side, I got to subtract x from the other side, or it's decimal equivalents. 10x, take away 1x, leaves us with 9x. 7.7 repeating, take away 0.7 repeating, leaves us with just 7. Step 4 says divide both sides by the coefficient to solve for x. So the coefficient, we're looking at the number or the value in front of x. When you have a number next to a letter, that means they're multiplying. So we're going to do the inverse operation, which is to divide. We're going to divide both sides by the coefficient, or divide by 9 on both sides in this case. And we get x equals 7 over 9. And if I test that out on my handy dandy, I go 7 divided by 9, and I get 0.7 repeating over and over and over. So that's problem number 1. I'll give you a second to look at it. Always feel free to hit pause when you're reviewing these videos. Problem number 2, 0.6 repeating. So same process. How many numbers are repeating? How many different digits are there in the sequence? Just one. So we're going to put x equals 0.6 repeating. We're going to multiply both sides by 10 to the first power, giving us 10x equals 6.6 repeating. Because again, when you multiply by a 10, you move the decimal point to the right one place. Next step is to divide both sides. Subtract one amount of x from both sides. Giving us 9x on one side and 6 on the other. Divide both sides by 9, or the coefficient in front of the variable. We end up with x equals 6 over 9, which can be reduced down to, oh man, slipped my mind for a second there. We're dividing both top and bottom by 3. So 6 divided by 3 was 2, 9 divided by 3 is 3. And if you punch in 2 divided by 3 in your calculator, you'll get 0.6 repeating again. All right. Problem number 3. 0.5 repeating. So step 1, set it equal to x. See how many digits are in the sequence? It's 0.5555, so just one digit. So we're multiplied by 10 to the first power, giving us 10x equals 5.5. Repeating. Step 3, subtract a single x. And what we had it set equal to at the beginning, which was 0.5 repeating. We're going to subtract that. 10x, take away 1x, gives us 9x. And 5.5 repeating, take away 0.5 repeating, leaves us with just 5. Divide both sides by 9. And we get x equals 5 over 9. Punch it into your calculator and you should get 0.555 repeating. That's problem number 3. Problem number 4. Problem number 4 is 0.3 repeating. Set it equal to x. See how many digits are in the pattern? Just one. Multiply times 10 to the first power, which is still just 10. We get 10x equals 3.3 repeating. Subtract one value of x from both sides. Again, the 0.3 comes from our very start, where we had x equals 0.3 repeating. So I'm going to subtract 1x on the left-hand side, and what x was set equal to, which was 0.3 repeating, from the right-hand side. 10x take away 1x is 9x. 3.3 repeating, take away 0.3 repeating, leaves you with just 3. Divide both sides by the coefficient of x, or in layman's terms, the value in front of the x, which is 9. And we get x equals 3/9, which can reduce down to 1/3, dividing top and bottom by 3. 1/3 is equal to 0.333 repeating. Next. Problem number 5. 0.345, all repeating. Set down the book for that one. So in this case, we have 3 digits in our sequence of repetition. So 0.345, 345, 345. So that's going to be 3 sets of 10. X equals 0.345 repeating. And we're going to multiply both sides by 10 to the third power, because we need to move it over 1, 2, 3 places. So 10 to the third power on both sides. What is 10 to the third power? That's 10 times 10 times 10, which equals 1,000. Or 10 with a total of 3 zeros, 1000. All right, so now we're going to multiply x by 1,000, and we get 1,000 x, and our 0.345 repeating by 1,000. So we're going to move the decimal point 3 spots over, getting one whole sequence of the repetition on the left-hand side of the decimal. And we go ahead and write down another series of the sequence that's repeating on the right-hand side of the decimal. Next. Step 3, subtract a single x from both sides for its decimal approximation. So we had x and it equaling 0.345. Repeating. So 1,000x, take away 1x, leaves us with 999x. And over here, that's going to get rid of our repeating decimal portion, leaving us with just the whole number, 345. We divide both sides by 999, which again is the coefficient of the variable, the value in front that's getting multiplied times the x. So we we get x equals 345 over 999. Now I think that can be reduced. If you want to use your calculator, you can see what goes into both of these. Being 999, I would see if 345 could be divided by 9, and it doesn't come out equally. But I know it can be divided by 3 equally and get 115 over 333. So if we divide both the top and the bottom by 3, we end up with 115 over 333. That's problem number 5. One left. Number 6. 0.27 repeating. So step 1, set it equal to x. X equals 0.27 repeating. Now see how many digits are in the repeating sequence. We have a 2, 7, 2, 7, 2, 7 sequence. So that's 2 digits. So we're going to multiply by 10 to the second power on both sides. 10 to the second power is 10 times 10, which is 100. So I'm going to multiply by 100 on both sides. So I'm going to go ahead and write that out. Again, when you multiply by 10 or 100 or 1,000, for each power of 10, you're going to move this decimal point to the right that many times. So 100x equals 27.27 repeating. So when you multiply times 100, that's 2 decimal points. 1, 2. So it brings a 27 out front, and then the 0.27 repeating goes on to the right. Step number 3, subtract a single x and its value from both sides. $100x, take away 1, leaves you with 99x. 27.27 repeating, subtract 0.27 repeating, leaves you with just the whole value of 27. Divide both sides by 99 to get x by itself. X equals 27 over 99. And again, I can divide 99 by 9, or I can divide 99 by 3. So is 27 divisible by 9? It is. 9 times 3 makes 27. So 27 divided by 9 is 3. And 99 divided by 9 is 11. So 3 11ths is equal to 0.27 repeating. And that concludes Unit 1, Lesson 4. Thank you.